Okay, so in this video what we're going to do is we're going to have a look at the cyclohexane chair conformations that we're given, and I'm going to use the Chem 3D Ultra to do that. First of all, I just want to get a clear understanding of how we're looking at these molecules. So notice here that on the left-hand molecule we have the ring puckered down, and also the same is true that we have the ring puckered down on the right-hand molecule here. So these chlorines are both in an axial position. So on the left-hand perspective, we're going to go anti-clockwise. So 1, 2, 3. And on the right-hand perspective, from that carbon, we're going to go clockwise. 1, 2. I beg your pardon. So 1, 2, 3 starting with that carbon, and 1, 2, 3 starting with this carbon here. So let's have a look at that now on the 3D Ultra. So this was what I mean, that we had the chlorine here, and we have carbon 1, and that corresponds to this carbon. And then we have carbon number 2, and we have carbon number 3. So we've gone round in an anti-clockwise fashion, and that brings us to that carbon that bears the chlorine. That was in an equatorial up position. So we can see it here, it's equatorial up. It's also equatorial up on our carbon here. So if we look at the right-hand molecule, remember that the carbon was axial, remember that the chlorine was axial down and the other chlorine was equatorial up, but it was facing in the opposite direction. So if I come around this way, we've got 1, 2, and then actually it's here 3. Now I'm going to just rotate round. So this is actually carbon number 1. This is carbon number 2. This is carbon number 3. This is carbon number 1. This is carbon number 2. This is carbon number 3. So what I'm going to do now is I'm going to rotate around so that we can see the molecules. And hopefully what you start to realize is that they are in fact mirror images of each other. If you imagine a mirror plane down this part here, and I mean it's easier to see on here, but you've got the three-dimensional thing here. Now if I try to take this and stack it on top, then yes, this carbon and this carbon, they will sit on top of each other. And if all I'm doing here is just rotating it around so that you can see it from a top-down perspective, then it's exactly the same thing. This is now facing left. This is now facing right. So actually this is perfect for viewing that these are in fact non-superposable mirror images of each other, thus they are enantiomers. Now when it comes to the naming of these, well, these are a 1-3 relationship, but we're going to now then talk about the stereocenters. So what I'm going to do is I'm going to just put the stereocenters on first, because it then makes it fairly easy to talk about. So if I go to atom here, I can put the stereochemistry, and these are both S. Now, why is that the case? Well, here we have priority number 1. So that's priority number 1, or A. If we go around this side of the molecule, then when we encounter this, that's going to be group 2. Now, if we went round this way, then we go around that way, that would be group 3. Okay, and then the hydrogen is facing forward. So we would actually, because the hydrogen on this carbon is facing forward, we have something that's moving around in a clockwise or seemingly clockwise direction. But don't forget that the hydrogen on this particular carbon would be facing forward, so that would become S. Now on this carbon here, we have same sort of deal. We have this here is our priority A. This way round the ring would be priority B. This way round the ring would be priority C. So we appear to be going anti-clockwise, but that's fine because the hydrogen here is actually pointed down. Here it is. So that hydrogen there is actually pointing away from us. Now when we come to look at the other one, then because both of these stereocenters are S, then the other ones, if they're enantiomers, should automatically be R. So I'm going to switch on then the stereochemistry for both, and that's exactly what was expected. So these are enantiomers. It would be 1S, 3S dichlorocyclohexane for the left-hand molecule, and it would be 1R, 3R 1,3-dichlorocyclohexane for the right hand. So the left hand was, let me just repeat that again, left hand is 1,S,3,S,1,3-dichlorocyclohexane. Okay, and that's that.